In this section, section 2.3, we'll look at polynomial division. In order to divide one polynomial by another, the divisor must have a lower degree than the dividend. The divisor is the one on the top. That's where the higher degree has to be. The dividend is the one on the bottom. That one has to have the lower degree. We will rewrite this using the old long division format that you probably learned way back in elementary school. The lower degree polynomial divided into the higher degree polynomial. Let's go ahead and practice this long division process using the example in number 1. I will do exactly what I said. I'll take the bottom one, the one with the lower degree, which is x plus 5, and say I'm going to divide that into x cubed plus 3x squared minus 6x plus 20. In order to start the division process, I'm going to begin by just thinking about the first terms. What is x cubed divided by x? Well, let's see, I had 3 factors. Get rid of one of them. I now have 2 factors of x. So x squared. That's the first part of my solution, x squared. Next, I'm going to multiply. I'm going to take that x squared and multiply it by the x plus 5. I'm going to put it right there. X to the third plus 5x squared. Finally, I'm going to subtract. When I subtract, this x cubed will turn into a negative, and the 5x squared will also be treated as a negative. I'm basically distributing the minus sign. And I'll get no x cubes left, but negative 2x squareds. That's one complete cycle of the long division process. We're not done, though. We have more terms. So I'm going to bring down the rest of the terms, negative 6x plus 20. And then I'm just going to do this all over again. I'm going to start by saying take negative 2x squared and divide it by x. When I divide, I'll get negative 2x to the first. So that goes into my quotient. And then I take that negative 2x and multiply it by the x plus 5. I'll put it right there. Negative 2x squared minus 10x. Once again, we want to subtract. And subtracting a negative is going to turn that one into a positive, and it's also going to turn that one into a positive. So I have no x squareds left, but I do have a positive 4x. All right, I still have a 20 to bring down, so we'll do that. And there's another complete cycle of this long division process. We'll keep going. I have 4x, and I want to divide it by that x. Well, 4x divided by x is 4. So plus 4 goes into my quotient. And then I'm going to take that 4 and multiply it by the x plus 5. Put that right there. That gives me 4x plus 20. And this time when I subtract, that becomes negative, there's nothing left over. So my quotient is x squared minus 2x plus 4. All right. Because the division in this case came out evenly, that is, there was no remainder, I actually now know that my original polynomial, the one from the numerator here, could be factored as the product of these two. If I multiply these two together again, I would come out with that. So the factored form is x plus 5 times x squared minus 2x plus 4. So it turns out this higher order polynomial with 4 terms here was factorable. However, would we have been able to factor it using our kind of usual factoring techniques? Let's take one more look at it. Normally, when we try to factor with 4 terms, we use a grouping method. If you had tried a grouping method here, you could have factored out an x squared and gotten x plus 3. And over here we could have factored out a negative 2, which would have given us 3x minus 10. Notice we've got a problem here. Right? If the grouping method is going to work, those two groups in the parentheses have to be equal. And in this case, they're not. So no, our usual factoring technique for 4 terms did not work. Long division was the only way we were able to discover this particular factored form.